Good morning, guys. Here we are. I am on Unit 16, Packet 16, and I am on page 2. You did page 1 last time. If you can't print out the packet, then you can just write the notes on a separate piece of paper. We are going to graph, so if you have graph paper, fabulous. If you don't, then you can just sketch the graphs. So we are going to graph exponential functions. So if you look, here is my exponential function right there. F of x equals 2 to the x. I can even highlight it if we want. That's my function right there. The reason it's called an exponential function is because the x is the exponent. Now you did this yesterday, those of you who came to Zoom, or those of you who did the work separately where you plugged in numbers for x. So what you're going to do is just go into the calculator and plug that into y equals. Now, right here, I gave you the table, y equals 2 to the x. If you notice, right here is a fraction, here is a fraction. Your table may come up as fractions or it may come up as decimals. I prefer decimals. I think decimals are easier to graph. When you graph this, you don't have to be perfect. And if you look, we can see, here you go. This is what it's going to look like. This is called an exponential. This is going up. So that is called exponential growth. Now, I gave you a bunch of notes. This is the asymptote where it will never cross this. I don't need you to worry about that. So you can just cross that out. Also, instead of having a slope, we have a common ratio. It does not go up in a common rate. It's just a common ratio, meaning you either multiply or divide. So if you look at, I'm going to graph 2 of them with you now. If you look at, let's compare what's happened when we changed our b value in the function. Now, if you look, if we graph y equals 2 to the x, what you want to do is go right to your calculator and plug in 2. You need the caret key to the x, and then what you're going to do is get your x and your y table. Now, if you look at your table, you're going to see that you go to decimals. So if I'm going to start at -2, -1, 0, 1, 2, 3. If you look, -2, I got 0.25. -1, I got 0.5. 0, I got 1. 1, I got 2. 2, I got 4. And 3, I got 8. Now, if you want to pause my video right now, go to your calculator, plug it in, and see what you get. Now, you might be saying to yourself, uh-oh, how do I graph a 0.25? Well, 0.25 is a quarter. 0.5 is half. So you fudge it a little. Remember I told you sometimes you can fudge these things? So if I go to -2, 0.25, it would be somewhere over there. If I go to -1.5, it would be somewhere over there. If I go to 0, 1, there. These are easier. 1, 2, 2, 4, and 3, 8 doesn't fit on my graph. It is going to be somewhere over there. So when I draw this, I connect my lines and I draw my arrows. And of course, we label y equals 2 to the x. And that's it. That's all you have to do. Now, if you notice, and I'll highlight it again, this right here, isn't this heading up? We read from left to right. So our line is going, it's not really a line, but our curve is going from left to right. So that is called exponential growth. It's growing. It's going up, okay? And if you notice, I gave you a little box. These are the notes right here. Exponential growth, it's getting bigger, and don't worry about b is greater than 1. That's just the number in front, okay? Which is here. That right there, the 2 is the B. Okay? So whatever I highlighted is what you can use in your notes. The next one, let's now graph the next one. So now it says y equals 1/2 to the x power. If you notice, the 1/2 is in parentheses. You must keep that there, all right? You must keep the 1/2 there. Now, I'm just going to draw a line, and I'm going to do my table down here, just so you can see it and have room. Okay, so this is the table to 1/2 to the x. Pause the video right now. Go to your calculator and find your table, write it down, then turn it back on and you look at mine. -3, -2, -1, 0, 1, and 2. And now I'm going to do 8. Now, I could write whatever -4 was, but it's going to be too high to fit on my graph, so you don't have to. Just try to get enough points so that you know what this is going to look like. There's no rule on how many points you have. And as you go down, 1 is 0.5, 2 is 0.25. You're going to get really small decimals. They're going to be too hard to graph. Don't even worry about them. Also, once you put this in y equals, before you go to your table, hit graph and look at the picture. Now, when I graph this, I'm going to go -3, 8, 1, 2, 3, 4, 5, 6. Oh, just missed it, but I'll put it in. -2, 4. Then I have -1, 2, 0, 1. And here comes the tricky part. 1.5. This goes like this. If you look at your calculator, you're going to notice something about this. It's never going to cross the x-axis. It's never going to go below the x-axis. Now, when you look at this we read from left to right, same way we would read a slope. So this is going down. So what do you think that's called? Instead of growth, we call this decay. Okay, exponential decay. And we're going to do a lot of words and problems with this. Exponential decay. So the only things I want you to take from this whole entire page is how to graph. Okay, so you know how to graph it. And then you know this one right here, whoop, here we go again, is growth. And this one right here is decay. And we have one more thing. Will these graphs ever intersect the x-axis? Now, you could go to your calculator and look at the picture. Does it ever cross the x-axis? No. You could also look at your table. Does it ever go? Do the y's ever become 0? No. So will these graphs ever intersect the x-axis? No. So, what I want you to do, and this is on your honor, I want you to turn off the video. And I want you now to do page 3, number 1, and number 2. When you're done, turn back on the video. So all you're doing is pausing the video. Do these 2 problems. Then turn the video back, unpause, and I'm working it out for you. You'll see exactly how to do these. So why don't you do that now? Pause the video and do page 3, number 1 and 2 now. Okay, welcome back. What I have now is page 3. I hope everybody did this on their own. Doesn't matter if it's wrong. You're just going to see how to do it and not worry about it. Okay? So, we'll do number 1. On a set of coordinate axes, graph y equals -5 to the x. So this is what I'm going to graph. Now, I wonder if some of you had this a little bit tricky. They want you to do, and this makes the problem easier actually. They want you to graph between -3 and 1. So you guys know what that means. Whenever they give you that, they're giving you the interval. They are telling you that you do not need to put arrows. I feel like you guys might remember that. So you went to your calculator and you put in y equals. So when I make my table, I'll make my table down here, okay? X, Y. I make my table, I'm gonna graph it between -3 and 1. Makes it a little easier. So this one is -0.008. Yipes. This is -0.04. This is -0.2. 0 is -1. And 1 is -5. So when I graph this, it does get a little tricky, but I come over here, I'm gonna go to -3, -0.008. It's right there. Fudge it a little, make it look like the calculator. -2, -0.04, -1, -0.2. See how I never hit -1 yet? Now I'm gonna hit -1. 0, -1. And then I have 1, -3, 4, 5. Okay, so now I'm going to connect it. Do not go from here to here. Do not put arrows. That's it. You just graphed it. You label it. Y equals -5 to the x. Don't forget there's a negative there. Be careful. Okay, that's it. You have full credit for the graph. The only other thing I do want to tell you is, because they might ask this, I want you to remember, and you didn't have to do this, you just needed your graph, but do you guys remember when we put quadrants? 1, 2, 3, and 4? Those were the quadrants. A lot of times, this will be a multiple choice question, and they'll ask, what quadrants does this graph lie in? Well, this graph lies in quadrants, what do you think? 3, 4. Let me ask you one more question. Is it growth or decay? Decay. We read from left to right, and this is going down. Good? Next question. And hopefully you did this. On the set of coordinate axes, graph y equals 3 to the x. So you plug that in the calculator. This is going to tell me what to graph it in between. So I do not need to use arrows. No arrows. So when I put that in the calculator, I'm going to get my table. I'll put it up here. And I'm going to graph it between -2 and 2. -2, -1, 0, 1, 2. When I go to my calculator, this one's a little neater. Looks a little better. 0.1, 0.3, 1, 3, 9. Not bad, right? So now when I graph this, -2, 0.1 is way down here. -1.3, 0, 1, 1, 3, and 2, 9 is going to come out here out of my graph. I'm going to connect it. I'm not going to write arrows. Hope this came out okay. And I'm going to label this. Y equals 3 to the x. You're done. That gets you full credit. You graphed it. Okay? Let's talk though. Let's talk a minute. Let's talk about our quadrants in case we'll get multiple choice questions. Here are my quadrants. This one happens to be in what quadrants, you guys? Shout it out. I'm not going to hear you, but you can shout it out. 1 and 2. One last question. Let's see if you remember. We read from left to right. Am I going up or down? Up. So what is this? This is exponential growth. Okay? Those are the two things. You have to know how to graph it. You have to know what exponential decay is and exponential growth. Send me a nice shot of this one page that you have, or just your sketches. If you don't have it printed out, it's fine. Just show your sketches so I know you have it. You'll get a 4 out of 4. And I'll hopefully be seeing everybody Friday on Zoom, and we'll go